Here we'll do a particular type of question in friction called a block over another block. Right here a block is placed over another block. Now a force is applied on one of the blocks. Now we have to find the acceleration of the blocks, right? So the main problem here is what is the type of friction acting between the two blocks and between the block and the surface, right? So that's the problem, right? If the blocks move, right, if the lower block moves, that means the friction between that block and the ground, so that is the kinetic friction. If the block does not move, that means the friction here is the static friction. Similarly, between the two blocks, what type of friction acts? So for that, first of all, we have to make sure, or we have to check whether these blocks move or not, or whether there is a relative motion between these two blocks or not. So only if you are sure that these two blocks move, that means there is relative slipping between the blocks, so can we use the kinetic friction, otherwise you have to use static friction. So for all these type of questions, so you have to first check whether there is a relative motion between the surface and the block and between these two blocks. Alright, so let us take some examples to understand this better, right? So we'll do some questions based on this block over block. Okay. Here we have a block of mass 5 kg kept on the ground. Another block of mass 3 kg is kept above this block, right? Now there is no frictional force between this block and the ground because the ground is smooth, the coefficient of friction, so that is 0. So that means, so this 5 kg block will definitely move because a force F is applied on the block. It will definitely move because there is no frictional force to stop it, so it will definitely move. But what about that 3 kg block? Will there be a relative motion between these two blocks? So we have to find the type of friction between these two blocks. Okay, if the friction is kinetic friction, then there is relative slipping, so these two blocks will not move with the same acceleration. But if the friction is static friction, then these two blocks will move together, right? Because there is no relative motion in that case, right? The relative motion happens only when the friction is the kinetic friction. Okay, so now we have to check whether it is a kinetic friction or static friction. That means we have to check whether the force acting on the block exceeds the limiting friction between the blocks or not. Alright, so let us do it. So what is the limiting friction between the blocks? Alright, so let us find it one by one. Okay, the first one, limiting friction between the blocks. So what is the formula for limiting friction? So that is limiting friction, so that equals, so mu multiplied by the normal force. So normal here is mg only, mu mg, but mu is given here, so that is between the blocks, so that is 0.2, and the mass of the object is 3 kg multiplied by 10, so that equals, so 6. So 6 Newton, so that is the limiting friction. Now the force on this block, is it more than or less than this limiting friction? So that is what we have to find. Okay, now, so, but we don't know, right, what is the force acting on the block? The only force acting on this block in the horizontal direction is the frictional force. But what type of friction? Is it the static friction or kinetic friction? We don't know which force acts, but assume, so initially we assume that the blocks move together. Okay, assume. So assuming that the blocks move together, that means no relative slipping, which means there is no relative motion between these two blocks. So what type of friction acts between them? So that is the static friction, right? No relative slipping, so that means it is a static friction. So the force acting on the block, a 3 kg block. So what are the forces acting on the 3 kg block? So the only force is the friction between these two blocks. That is the only force which may drag this block in the horizontal direction. So what is that friction? That friction here is the, see, blocks move together, that means no relative motion, that means it is the static friction. So what is static friction? So static friction does not have any formula. Alright, static friction is simply, see, what is the force? The only force, so F. So that is the force. Okay, that equals, that is the only force, mass times the acceleration. What is the mass? So 3 multiplied by the acceleration. Okay, yes, so this is for the 3 kg block. Okay, now for the 5 kg block, or 3 plus 5 kg block. Okay, both the blocks together, we are taking these two blocks together because they are moving together. We assume that they move together, so consider them as one system. Now 3 plus 5 kg. What are the forces acting on this system? The only force is F. F, the applied force, F. So that equals mass times the acceleration. So mass is 3 plus 5 multiplied by the acceleration, same acceleration as the blocks move together. Okay, so that's all. So this will give you the acceleration value. So the acceleration here is equal to F divided by 8. Okay, done. So F by 8 is the acceleration. Okay, now this acceleration is found, but in the first case the value of F is also known. So the first question, the value of F is given to be, so F value is given, right, the force acting on the block, so that is 15. That means the acceleration here is, so 15 divided by 8, so that is the acceleration. That acceleration we can substitute here in this, the frictional force, right? What is the frictional force we are getting between the blocks? So that equal to 3 multiplied by 15 by 8, so that is 45 divided by 8. But the friction between these two blocks should be less than, because it is static friction, so friction between the two blocks should be less than the limiting friction. Is it less than or more than the limiting friction? So the limiting friction is 6 Newton, right? So here it is 45 by 8, so 45 by 8 is, so less than the 5 point something, right? So this is less than the limiting friction. That means our assumption is correct. See, we have assumed that the blocks move together. That means the friction here is static friction. So we got the static friction that is less than the limiting friction. So our assumption is correct, which means, so what we have assumed is correct. The blocks are moving together. When the blocks are moving together, so no problems. What is the acceleration? So that is the acceleration. Whatever we found, that is the correct acceleration only. So that implies we can conclude that the acceleration equals 15 divided by 8. So that's all. So that is the required answer. Do you understand? So that is the answer. Suppose this frictional force is more than the limiting friction, so that is not possible. That is a contradiction. So this is the method we are going to use for all this block over block question. What is that? Initially you find the limiting friction, and first of all you assume that, because we don't know, right, you assume that the blocks are moving together, right, they will have the same acceleration. Then whether the result which we got is consistent with this or not. Okay, so accordingly we can decide whether the accelerations are same for these two blocks or not. But in this case, so the frictional force between the blocks is less than the limiting friction. That means, so we're right. So the blocks move together with the same acceleration, 15 by 8 for both the blocks. The acceleration is same, 15 divided by 8, right? So that is the first case. Now the next case, right, the force is 20 Newton, right? So the second case, so the force is given to be 20. Okay, so in that case what is the acceleration, right? So tell me. So F is 20 here, so the acceleration here is 20 divided by 8, so that implies the acceleration is 20 divided by 8. Okay, so that equals, so 20 by 8, so what is it? So this is 2.5. Is it more or okay, that acceleration can be substituted here. So this implies the force between, the frictional force between the two blocks that we have already found. So that is 3 times here. So 3 multiplied by 2.5, so that is 7.5. So this is the frictional force. But we've got the limiting friction 6 Newton only, but we've got frictional force 7.5. How can the friction be more than the limiting friction? So this friction is more than the limiting friction. So that is not possible, which means our assumption is wrong. Okay, so what is our assumption? So we assume that the blocks move together, but that assumption is wrong, because so that gives you some observed result. What is that? The friction is more than the limiting friction. Not possible. That means we understand that the blocks move separately. Okay, they move the different acceleration. That means what? There is some relative motion between these two blocks. These blocks do not move together. Now they move separately. So that means, so let us consider these two blocks separately. So what is the force acting on the 3 kg block? So this time it is kinetic friction, not static friction. When there is a relative slipping between the two blocks, then the friction is the kinetic friction. Kinetic friction has a fixed formula. What is that? Mu times normal, right? Mu mg here. So the only force acting on the upper block is the frictional force between the two blocks. So that means, so mu mg, that is the only force acting on the block. That equals mass times the acceleration. Mass times the acceleration of the 3 kg block. Okay, I'm writing A3. Okay, the acceleration of the 3 kg block. So this gives you the value of A3. So m gets cancelled, and then mu. So mu value is known, right? That is 0.2 multiplied by g. So that is 2. So that 2 meter per second square, that is the acceleration of the 3 kg block. So that is different. Now we have to find the acceleration of the 5 kg block. What are the forces acting on the 5 kg block? Of course, the force F in the horizontal direction, so that is 20 Newton force in the positive direction, minus the friction between these two blocks in the backward direction, this direction, opposite direction, right? Because so that friction between these two blocks, okay, so that works in the opposite direction, right? For the upper block, the friction is in this direction, but for the lower block, the same friction is in the opposite direction, okay. So 20 minus, that is again kinetic friction, mu mg, so that equals the mass times the acceleration. But what is the mass here? 5 times the acceleration of the 5 kg block. This is the acceleration of the 5 kg block. But remember, this m is not mass of the lower block, it is mass of the upper block, right? The friction here is due to the upper block only, right? So the normal force is same as the due to the mass of that block, right? 3 kg block. So same force here, mu mg, here also mu mg, because friction is same between the two blocks in the first case and second case, okay. But 5 is the mass of the lower block, okay, because we are finding acceleration of that block. So mu mg already found, so that is okay. So this is 20 minus, so mu is 0. So mu is 0.2 and mass is 3 multiplied by 10 is equal to 5 multiplied by acceleration of 5 kg block. So that gives you the acceleration of the 5 kg block. So what is this? This is 20 minus 6, okay, it's 20 minus 6, so that is 14 divided by 5. So 14 divided by 5 is 3.5, okay, so that's alright, sorry, 14 divided by 5, so 14 divided by 5 is 2.8. So that's all. So that is the acceleration of the 5 kg block, okay. So these two accelerations are different, okay, these two accelerations are different, and here the accelerations are same because these two blocks move together. See, obviously the acceleration of the 3 kg block is less than the acceleration of this block because this moves faster, that is why there is a slipping. That means the upper block moves slower than the lower block, okay. So this has acceleration 2.8, so in this case the acceleration is 2, but in the first case both of them have the acceleration, this 15 by 8, okay. So that is the answer. This question is similar to the last question. Here also we have two blocks, a force is applied on the lower block, but this force is not given, right? We have to find a range of the values of this force F so that these two blocks move together, right? And also this ground is not smooth. There is a frictional coefficient of 0.2 between the block and the ground, okay? So we have to find the limiting friction not only between the two blocks and also between the lower block and the ground, okay. So these two limiting frictions you have to find, and we have to check whether this limiting friction is more or less than the force on these blocks, okay. Yes, let us find the limiting friction. So the limiting friction between the blocks, so that is FL, right? So that equals mu mg, okay, normal is mg only, so mu between the blocks, that means it is 0.3, and the normal force is due to that 3 kg block only, so that means it is 3 multiplied by g is 10, so we can take say 9, so 9 is the limiting friction between the blocks. Similarly, so we can find the limiting friction between the lower block, okay, or 5 kg block, okay, between the lower block and the ground. But this time the normal force is not only due to the 5 kg block, it is also due to the 3 kg block. So the total weight is 3 plus 5, so that is 8 kg, right? That is the total mass, right? So we have to consider, see, that FL equals mu, same mu mg only, but what is this m? M is not only due to that lower block, because the whole weight is on the ground, so that means 8 kg. So but the frictional coefficient is between the ground and that block, so that is 0.2, and then this mass is the total mass of the two blocks, so that is 8 multiplied by 10, okay. So this gives you the value 16. Now 16 is the limiting friction, right, between, okay, so we call it, so FL1, okay, first, because we use the same symbol here, 2. So 2 is the limiting friction between the block and the ground, and this is between the blocks. Okay, now this lower block will move only when the applied force is more than the limiting friction for the block to, for lower block to move. For the 5 kg block, for the 5 kg block to move, for the 5 kg block to move, the applied force should be more than the limiting friction. So F should be more than the limiting friction between the block and the ground. So F should be, so this gives you one relation, F should be more than, this is found already 16, so F is more than 16, that's all. So that is one of the condition, F should be more than 16 for the lower block to move. Okay, so okay, that's all. So now that is one condition. Now we consider the upper block, okay, assuming that the blocks move together. Assuming that the blocks move together. When the blocks move together, so that is the static friction, right, between the two blocks. So what is the force acting on that block, the upper block? So that is the only the friction between the two blocks. So the 3 kg block. So let us write the forces acting on the 3 kg block. So that is the static friction. Static friction does not have formula, simply use the symbol F. F is the force acting on the upper block. So that equals mass times the acceleration, 3 times the acceleration. Okay, so 3 times the acceleration. Okay, so yes, now that is for the 3 kg block. Okay, now for the 5 kg block. Or these two blocks move together, so we can take it as 3 plus 5 kg block. Okay, for this total system, so what are the forces acting on this system? The applied force F, okay, F, minus the friction between these blocks and the surface, right? So that is the, see, that is the kinetic friction, right? Because these blocks, that should be the kinetic friction because it should move. So that means it is minus mu mg. So mu here is 0.2 and m here is 8. Okay, and g is 10, so mu mg. So this is the total force acting on this system. Okay, force in this direction and the friction in the opposite direction. Okay, so that must be equal to mass times the acceleration. That means 8 times the acceleration. Okay, so that's all. So this is one of the conditions. Okay, so now what do we do? So this force, okay, so let us calculate this one. So F minus, what is this value? The acceleration from this one is F minus, this is 2 multiplied by 8, 16. F minus 16 divided by 8. That is the acceleration we got from the second equation. That can be substituted in the first equation. Okay, so this you substitute here. So that will give you the frictional force. Alright, so let us calculate that frictional force. Okay, so that equals, frictional force equals 3 multiplied by acceleration. So that is 3 multiplied by this acceleration, that is F minus 16 by 8. So F minus 16 divided by 8. So that's all. This is the frictional force. But what is our condition? The frictional force between these two blocks should be less than the limiting friction. The limiting friction is 9. So this frictional force is less than, the frictional force between the blocks is less than the limiting friction between the blocks. So limiting friction is 9. So this value should be less than 9. So that is the condition. Okay, so simplify this. So we'll get the answer. So that is 3 multiplied by 8. So F is less than, okay, so this is 3 multiplied by 8, 24. 24 plus 16, so that is 40. So that's also, this is one of the conditions. Already we've got a condition, so F is greater than 16. Now we've got F less than 40. So that means, so our required force F should lie between these two values, right? 16 and 40. So that is the required answer, right? If F lies between these two in this range, then these two blocks will move together. Okay, so two conditions: the lower block should move. For that, the friction between the lower block and the ground, right? So that friction, limiting friction, should be less than the applied force. Similarly, the upper block should move with the lower block. So that means there it is a static friction. So for that, again, the friction should be less than, the limiting friction. So that is the condition we have used to get this answer. So F lies between 16 and 40. Okay. Here also we have two blocks of mass, 5 kg and 3 kg, same numbers, right? 5 kg and 3 kg. I should have changed the numbers, but anyway, the method works just fine with any mass. So this time the force is acting on the upper block, right? So now 30 Newton force is acting on the 3 kg block. Now we have to find the accelerations of the blocks. Okay, yes, same method, no difference. Let us find the limiting friction between the two blocks. Okay, yes, so limiting friction. So the first one is the limiting friction between the blocks. So that is FL equals mu mg. So that mu is given 0.1 multiplied by the mass of the object is 3 multiplied by say 10. So that equals 3. So this is the limiting friction between the blocks. Similarly, limiting friction between that 5 kg block and the ground. Okay, so that limiting friction also we have to find FL. So we take it as FL1, FL2. Okay, so between the ground and the block. So that is again, so mu mg, but mu, what is mu? That is 0.3, but m is not the mass of the 5 kg block because the total weight we have to calculate, right? So that is 3 plus 5, 8. So mu m is 8 multiplied by g. So that equals, so that is 3 multiplied by 8, 24. So that is the limiting friction between the ground and the block. Okay, yes. Now as usual, assume that the blocks move together. That means no slipping between the two blocks, right? So assuming, okay, so assume that the blocks move together. That means they have the same acceleration, one thing, and also the friction between the upper block and the lower block, that is the static friction, because the blocks move together, so no slipping, so static friction. But friction between the two blocks and the ground, that is kinetic friction, right? Because the blocks are moving, right? The relative motion is there, so that means that is kinetic friction, but between the blocks it is a static friction. Okay, so that means, so what are the forces acting on the upper block, say 3 kg block? So 3 kg block, what are the forces acting on the block? So that is the static friction. Static friction we don't know, so we have to just take it as F only. F is the force which is dragging this. Now sorry, F is acting in the opposite direction. So the force in the forward direction, that is 30, because the force this time is acting in the upper block, so that means plus 30. 30 is the force acting in this direction, and in the opposite direction, because of the lower block, the friction between them, so that is minus, right? Minus F in the opposite direction. So 30 minus F, that is the total force acting on the upper block. So that equals, so mass times acceleration, so 3 multiplied by the acceleration. Okay, now 5 kg block, not 5 kg block, because the blocks move together, we consider them as a one system. So that means 3 plus 5 kg, right? Total 3 plus 5 kg block. For this system, what are the forces? The 30 kg, the 30 Newton force is acting in this direction, so 30 for the whole system. Now friction between the blocks we need not consider, because that is internal. So this is one system. The friction between ground and the block, so that is acting in the opposite direction, but that is kinetic friction. Kinetic friction has the formula, right? What is that? Mu mg. So that is same formula, mu mg, that is 0.3. M is 8 here, 8 multiplied by g. So that equals mass times the acceleration. So that is 8 times the acceleration, same acceleration as the blocks move together. Okay, so that's all. So this will give you our required acceleration of the two blocks. So that is from this. So 30 minus, so this is 24, right? It's 6 divided by 8, correct? 30 minus 24, so that is 6 divided by 8, or we can say 3 by 4. So that is the acceleration. Okay, so that acceleration you have to substitute in this equation. So if you substitute it back here, that will give you our frictional force. So that friction equals, so what is that? So 30 minus 3 times A. So 30, okay, let me write it. 30 minus 3 times acceleration. Acceleration is 3 by 4. So what is this value? Yeah, so 30 minus 9 by 4, right? So that is 120 minus, right, 120 minus 9. So it is 111 divided by 4. Now is it more or less than the frictional force, right? Is it more than or less than this limiting friction? So this is only 3, right? This is bigger, right? This is greater than the frictional force, right? Limiting friction 1. So this is the friction between the blocks. So this is the limiting friction between the blocks. So that is not possible, right? Because limiting friction should be bigger, right? So this is not possible. That means the blocks do not move together. So these two blocks do not move together, so they move separately, right? Because so the frictional force here is more than the limiting friction, so that is not possible. So now we will consider these two blocks separately. Okay, so what are the forces acting on these two blocks separately? Okay, so the conclusion is that the blocks move, okay, separately, which means they have different accelerations. Okay, now let us consider the 3 kg block. So what are the forces acting on the 3 kg block? So the 30 Newton force is acting in this direction and the frictional force is acting in this direction, but this time the frictional force is the kinetic friction because they move separately. That means there is a slipping, right, between these two blocks. So it's a kinetic friction. So kinetic friction formula is what? Mu mg. So that is 0.1 m is 3 multiplied by g. Okay, so this is the total force acting on the upper block. So that must be equal to mass times 3 times the acceleration of the 3 kg block. Okay, A3. Okay, acceleration of the 3 kg block. So that gives you our required acceleration. So what is that? 30 minus 3, that is 27. 30 minus 3, 27 divided by 3. So that gives you the acceleration, that is 9. So 9 is the acceleration of the upper block. Okay, now for the lower block, 5 kg block. What are the forces acting on the 5 kg block? So the friction between these two blocks, right, that is acting in this direction, that is dragging this. That 3 kg block is what is dragging this lower block, right? That means the friction between them is acting in the forward direction, and friction between the 5 kg block and the ground, that is acting in the opposite direction. You understand? So in both the sides friction force only, but the upper friction is acting in this direction. So friction due to the ground, that is in the opposite direction. So but both the frictions are here kinetic frictions only. Okay, because we assume that the 5 kg block is moving. Okay, so now let us calculate. So what is the friction in the forward direction? So that is the same thing, right? This friction, kinetic friction. So that is 0.1 multiplied by 3g. So that is the friction in this direction. Now friction in the opposite direction. So minus, so that is due to the ground. So what is that friction? So that is 0.3. Okay, mass is due to the total mass, right? The normal force is due to both the object, right? 3 plus 5, so that is 8. 0.38 multiplied by g. So this is the friction in this direction and this is the friction due to the ground in the opposite direction. So that must be equal to mass times the acceleration, which is 5 times the acceleration of the 5 kg block. Okay, yes, now that's a simple calculation. So we can get the required acceleration of this 5 kg block. So that is, so what is this value? 3 minus 24, right? So 3 minus 24, so that is minus 21 divided by 5. So that is the acceleration? No, this is not the answer. See, acceleration of the 5 kg block, that is negative. How is it possible? That means the block is moving in the opposite direction. Is that even possible? The friction is acting in this direction. So that means the friction this side is more than the friction due to that block in the positive direction, right? This friction is more, right? That's why we're getting negative. But is it practically possible for this block to move this side? Either it will stay in that position or it will move in the forward direction, never in the opposite direction, right? So that means this is not possible. So what is the conclusion? It is not moving. So friction in this direction is more than the friction in the positive direction. That means the object does not move. So this does not mean the object is moving in the opposite direction. So the acceleration of the 5 kg block is 0, right? Because we have used kinetic friction, but we don't even know whether the object is moving or not, right? The upper block is moving. The lower block, is it moving? We don't know. But we have used kinetic friction. So we use this kinetic friction. See, friction between upper block and lower block, that is kinetic friction, no problem. But lower block and ground, is that kinetic friction? We don't know, right? Maybe static friction. So we've used the kinetic friction. So that is why we are getting this result. Negative, not possible. That means we should have used the static friction. So when you have static friction between the block and the ground, obviously the object does not move. So acceleration is 0. Do you understand? So acceleration of the lower block is 0 and acceleration of the upper block, so that is 9 meter per second square, right? So that's all. So that is the required answer. here a block moving with speed u in air, right, that lands on a plank. That plank is placed on a smooth surface. So as the block lands on the plank, so both of them will move together, right. So this plank will slip over this plank for some time. After some time, so both of them will move with the same speed, right. So we have to find the time taken for that to happen, right. So initially the block will slip, which means there is a relative motion between the plank and the block, right, relative motion. But after some time they both move together, so we have to find the time taken for these two blocks to start moving together. Okay, so that we have to find. The lower block will obviously move because this is a smooth surface, there is no resistance, no friction, so this block lands on this, so that means this plank will also start moving. Okay, what is the force acting on this lower block, I mean the plank? That is the friction, right. So when that block is placed on the plank, so that will start moving, right, this will start moving. So the only force acting on the plank is the friction between these two. Okay, similarly that block, right, that block, when it moves in this direction with speed u, there is no force acting on it. Okay, it will move in this direction without any force acting on it in the horizontal direction. But when it is placed on the plank, then friction acts in the opposite direction. That is why it slows down, right. Initially the speed of that plank is less than the speed of the block, but after some time both of them move together, which means the speed of the block is reduced. So what reduces the speed? That is the friction, right. Friction works in the opposite direction, so that reduces the speed. Okay, yes, now let us write the equation for the block, right. So block M. What are the forces acting on that block? So that is the friction force, right, that is the kinetic friction, right, because initially it is slipping, so there is a relative motion between them, so it is a kinetic friction. So kinetic friction formula we know, right, so that is mu mg. So mu mg is the only force, but in the opposite direction, minus. Okay, minus mu mg is the force. That equals mass times the acceleration, so that is mass times the acceleration. Okay, so we can call it acceleration of m, right, small m, right, acceleration of that block. So that gives you the acceleration of that block, so that is minus mu g. So that's the acceleration of the block m. Now similarly we'll find the acceleration of the lower block, right, or the plank. Okay, plank, capital M. Okay, what are the forces acting on the plank? So that is again the same frictional force only, but in the forward direction, this direction. The plank is moving in this direction, so that means the same frictional force acting on this plank makes it move in the forward direction. So in this direction, positive direction, that means mu mg is the force, mu mg. So that is the same force, right, same force but in the opposite direction. That equals mass times the acceleration. So acceleration is taken as okay, capital am. Okay, so done. So this is the acceleration then, mu mg divided by, so capital M. Okay, that's all. That is the acceleration of the lower block. But after some time both of them move together. What will happen when they move together? Their velocities are same. That means the relative velocity is zero, right? When they start moving together, they have the same velocity, so the difference is zero. Relative velocity is zero. So for that we have to find the relative acceleration. Okay, so what is the relative acceleration? We don't want the actual acceleration, so the relative acceleration A equals the acceleration of the block minus the acceleration of the plank, right? So that's it. So that we can calculate. So that is minus, okay, so that is minus mu g minus mu mg divided by m. So this is the acceleration, the relative acceleration. We want relative acceleration because we are going to find the relative velocity. So the relative velocity is 0. The relative velocity is 0 when they start moving together. Okay, when they move together, that is the point when the relative velocity is 0. But what is the initial relative velocity? Initially the block is moving with velocity u, but the plank is at rest. That means the relative velocity initially is u minus 0, u only, but the final velocity is 0. Initial velocity is known, final velocity is known, acceleration is known. So what is the formula? So we know the formula. So v is equal to u plus at. Okay, v equals u plus at. V is the final speed, so that is 0. initial speed is u, and acceleration, so the acceleration is this one, so minus of, okay, if you take out minus of mu g plus mu mg divided by m multiplied by t. So that's all. So that will give you our required value of t, right? So that's all. So what is the value? So u, if you divide it, u divided by mu g, okay, so that gives you required value of t. So t equals u multiplied by u divided by mu g. Mu g if you take out, you will get 1 plus m by m, 1 plus m divided by m. That's all. So that is the required answer, okay. So that's all. If you simplify this further, so we'll get, so u multiplied by m divided by mu g multiplied by m plus m. So that's all. This is the time taken for this two blocks, okay, to move together, which means the block starts slipping, right? I mean the stop slipping, right? Which means these two objects move together after this time, okay. So um divided by mu g m plus m, that is the answer. Here two blocks placed on the ground are connected by a string. We have to find the tension in the string, right? So there is an 8 Newton force acting in this direction on this 3 kg block, acting in this direction, 1 Newton force in this direction. So what is the acceleration of the blocks? First of all, let's find the acceleration of the blocks. But both the blocks will move together only, if at all they move. So let us find the acceleration. So there will be acceleration, which means the blocks will move if the total applied force is more than the limiting friction. So when you say limiting friction, so that is the total friction, right? Total limiting friction of the 2 kg block and 3 kg block. So what is the total force acting on this system? That is 8 Newton force in this direction, and then 1 Newton force in this direction. So 7 Newton, that is the effective force, right, in the positive direction. Is this force 7 Newton more than the limiting friction? So let us calculate the total limiting friction. Total limiting friction. So what is that total limiting friction? FL. So that equals, due to that 2 kg block and also 3 kg block. So for the 2 kg block, 0.1 mg, mg is 2g plus 0.2 multiplied by that is 3g, okay. So this is 2 plus 6, so 8, so 8 Newton. So that is the total limiting friction. Is it more or less than the total force? So the total force acting on the system, that is 8 minus 1, okay, 8 in this direction, 1 in this direction, so that is 7. So this limiting friction FL, the limiting friction, is more than the force. That means the object will not move, right, because the friction is more than the force. That means the acceleration of the object is 0. Acceleration is 0, okay. So both the objects, right, so they do not move, that's all. So now tension we have to find. How to find the tension? So these two blocks do not move together. So what will happen? So let us find the tension. So what is, now we will calculate only for that 2 kg block, okay, for the 2 kg block. For the 2 kg block, what is the limiting friction? So that equals, so that is only this much, right? So 0.1 multiplied by 2g, that equals 2. So 2 is the limiting friction, but what is the force acting on that, right? The force. So force F is equal to, so that is 1 Newton in this direction, 1 Newton in this direction. So that means, so this limiting friction is more than the force. That means, so that block has no tendency to move only, because again you see the friction, no tendency to move in this direction, right, the negative direction, because the friction is 2 but the force is only this much, so no tendency. See, already we have proved that these two blocks, they don't move, okay, but this block doesn't even have the tendency to move, okay, it is not trying to move only. If it tries to move, then the tension will prevent that. But there is no role for the tension here, right? Tension is not even required for the block to be at rest. This 2 kg block will be at rest even without that tension. So tension is not required because already the 1 Newton force is less than the friction. So even without tension, this block will not move. Okay, so this block, 2 kg block, has let me write like this, to no tendency to move. For understanding, I am writing like this, tendency to move, which means it is not trying to move. If it tries to move, then the tension will start acting, but no need of any tension here. So this block anyway does not try to move. Okay, so that is for the 2 kg block. Now for the next one, 3 kg block. So what is the force acting on 3 kg block, or the limiting friction? Let us calculate. So limiting friction for the 3 kg block, so that is 0.2, and then the mass of that is 3 multiplied by g, that is 6. But what is the force acting on the block on the to the right? So that is F equal to, so the force is 8 Newton. But this time the force is more than, so force is more than the limiting friction. Okay, unlike here, so that means the object will not move. Here also the block is not moving because already we have done this. The block does not move, but it has some tendency, it will try to move. That is prevented by the tension. So see, if the tension was not there, 3 kg block will move because the force is more than friction. But even if tension was not there, this 2 kg block, that wouldn't move, that will stay there only even without tension. You understand? So tension makes a difference for the 3 kg block, but tension doesn't make any difference for the 2 kg block. You understand? So that means that 3 kg block tends to move. The 3 kg block tends to move, it tries to move. Okay, then the tension will prevent it. Tension and friction, both these forces will try to prevent that. Okay, but here for this 2 kg, only tension is preventing the block from moving. But for the 3 kg block, both tension and friction. That means the friction acting on the 3 kg block is maximum. You understand? That is not the case here. So the friction is the maximum friction. The limiting friction is reached because it tries to move. The friction prevents that. So that means the maximum friction is used. So what are the forces acting on this 3 kg block? So the 8 Newton force. So for the 3 kg block, again we'll write the equation, that 8 Newton force in this direction, tension in this direction. But what tension? That is the friction. What friction? Limiting friction, right? Because maximum friction is required to prevent that block from sliding. Maximum friction. What is the maximum friction? That is the kinetic friction only, or the limiting friction. Both are same here, mu value is anyway same. So it is 0.2 multiplied by 3g. So this is the friction acting in the opposite direction. Tension is also acting in this direction, minus t. So that equals 0. If you do the calculation, so 8 minus 6, right? So that means t equals 2. That's all. So 2 is the tension, right, in the string. Okay, yes, that's all. So that is the tension. See, what we did here is simple. First, we checked whether the blocks move or not. So from this, we understood that the blocks are not moving. Both the blocks are at rest. But from this, we understand that the 2 kg block is not even trying to move, right? Because the friction force, right, is more than the applied force, 1 Newton. So that means the block is not even trying to move even without that tension. Okay, which means we don't know the exact friction acting on the 2 kg block. It is a static friction, right? Maximum friction is not required. Okay, so it is only static friction. But the second block, that is trying to move because 8 Newton force is more than the limiting friction, right? That means that block is trying to move. That means the tension and the friction, they prevent the block from moving. That means maximum amount of friction is used. So that's why we use the maximum friction. So forces acting on the block are 8 Newton force and also tension and the maximum friction. That means the limiting friction or the kinetic friction in this case. So force, maximum friction and tension, these are the forces acting on the block, but the block is anyway not moving, so 0, right? Acceleration is 0. So from this you find the tension in the string, so that is 2 Newton. Okay. Here also we have two blocks connected by a string. We have to find the tension in the string and the acceleration of the blocks. But the force F is not given here. We have to consider various cases, right? So for different values of F, what is the acceleration and the tension, right? That's what we have to find. Same method. So we have to find the limiting friction for both these blocks, alright? So for this 8 kg block, So what is the limiting friction? So 8 kg block. So FL, so that equals, so mu mg, so mu here is 0.4, so 0.4 mg is 8 multiplied by g, so that is, so 32, so that is the limiting friction. And then similarly for that 6 kg block, so for that the value of FL equals 0.3 multiplied by 6g, so that equals 18. Alright, that means what is the total? So total FL for these two blocks together, so the limiting friction, so that equals 50, which means our force should be more than 50 for these two blocks to move, right? If the force is less than 50, the acceleration is 0, okay? So whatever is the force but less than 50, the acceleration is 0. Only when the force is more than 50 will the blocks move, okay? Yes. Now what we have to consider many other cases, like if the force F is less than 18, what will happen in that case? See, let's take the first case. The force F is less than 18. If the force is less than 18, that means this force is less than the limiting friction of that 6 kg block only. That means 6 kg block itself does not move, but does not try to move only. See, if it is less than 50 itself, it does not move, but that 6 kg block itself does not try to move, okay? There is no tendency of this 6 kg block to move, so no tension is required, right? So the friction itself is stopping the block from moving. So what is the use of tension? So tension is 0. See, when F is less than 18, 6 kg block doesn't tend to move, doesn't move, that we know already. It doesn't tend to move only, okay, because friction itself is stopping that block from moving. So that means what is the tension then? 0, right? Because no need of tension, right? Even without tension, that 6 kg block is not moving. So that means the acceleration of the block is 0 and tension is also 0, okay? Acceleration is 0 for all the cases less than 50, but tension is also 0 in this case, okay? So that is the first case, less than 18. Okay, now let us take the next case. Okay, so more than 18, so 18 less than F, less than 50 directly, right? No need of 32, so 50, because till 50 the block is anyway not going to move, okay? So if the force F is greater than 18, that means again acceleration is 0. See, acceleration is 0, both the blocks, they don't move, but that 6 kg block will try to move this time, because the force is greater than 18. The force is greater than the frictional force. When the force is greater than frictional force, the object will try to move, then the tension has to stop this object, right? So that means tension starts playing only when F is greater than 18. Do you understand? So this time tension is non-zero. So in the previous case, tension is not required to stop that 6 kg block, but this time tension is required. So what is the tension? So let us calculate that. See, the moment F is greater than 18, so what type of friction is acting? The maximum friction is acting, right? Because the force is more than the friction, the limiting friction, that means maximum friction is acting. That means that 6 kg block, what are the forces acting on the block? In the forward direction. So that is F minus tension is acting in the opposite direction minus the frictional force. What type of friction? Not static friction. Maximum friction is working. Maximum friction is what? That is same as the kinetic friction, right? Because mu value is same anyway. So that is that 18 only. Let me write it again. So 0.3 multiplied by 6g. So that equals 0, because the object is not moving anyway. So that will give you F value. So this will give you the tension, sorry. The tension equals F minus, so that value, what is that? 18. So F minus 18 is the tension. See, F is variable, so we don't know exactly, but whatever is F, right? For example, if F is 20, if F is 20, 20 minus 18, that is 2, okay? So whatever is F, but lying in that interval only, then the tension is this, but acceleration we know already 0. Because the object is not moving when the force is less than 50. Okay, that part is done. Now when the object is when F is greater than 50, when F is greater than 50, then the force exceeds the total limiting friction. The total limiting friction only is 50. The force is more than 50. The object will start moving. So both the blocks move here. The blocks move. When the blocks move, then the acceleration will be same, right? Blocks move, then the friction acting on the blocks, that is the kinetic friction. Kinetic friction and also acceleration of both the blocks are equal. So let us use our equation here. So what are the forces acting on that first block? So that is F in this direction. So that is 6 kg block. For that 6 kg block, F is acting in this direction. And also friction, which friction? Maximum friction or the kinetic friction. So what is kinetic friction? So that is or we can directly write, so that is same thing, right? 0.36 g, so that is 18. Let me write directly 18. And tension is also acting in the opposite direction, that equals mass times the acceleration, so 6 times the acceleration. Okay, so this is for 6 kg block. Similarly for 8 kg block, for that 8 kg block, so what are the forces? Tension in this direction, friction in the opposite direction. So tension minus friction in the opposite direction. What is the friction? So that is 32, right? Because 0.4, same thing we are going to write, 0.48 g, so that is 32. So T minus 32, so that equals 8 mass multiplied by acceleration, same acceleration. When the objects move, they will move with the same acceleration, right? They are connected by the taut string. So that's all. You solve these two equations, we get our required acceleration of the block. All right, so you just add these two. Okay, you will get the answer in terms of F only, right? Because F is not exactly known. So you add these two, will get T will get cancelled. So we'll get the acceleration. Okay, so let us solving this. Let's solve this. Solving, we are getting F minus 50. So F minus 50 is equal to, this is 8 plus 6 plus 8. So that is 14. So F minus 50 is equal to 14a. So that means we are getting acceleration. So F minus 50 divided by 14, that is the acceleration of the two blocks. Okay, yes, so that's all. So that is done. So you substitute that acceleration here, okay, in any one of the equations. So we will get the tension. I substitute it here. So that implies tension equals 32 plus 8a. So 32 plus 8a, but a is known, that is F minus 50 divided by 14. Okay, so if you simplify this, so if you do the simplification, you will get this is 4, this is 7, right? 7 multiplied, okay, 32 plus 4, 4f minus 4 multiplied by 200 divided by 7. So that if you do, so just a calculation, right? So we have to do the calculation. 32 multiplied by 7, that is 224 minus 200, that is 24. 24 plus 4f divided by 7. So or if you take 4 out, you get f multiplied by f plus 24. So 4 is taken out, so that is 6 divided by 7. So that's all. So this is the tension in the string, in this case when the force is more than 50, and the acceleration in that case is this. So this is the acceleration and this is the tension in the string in the last case. Okay, so here we have acceleration 0, tension is F minus 18. In this first case, so both the values are 0. Alright, so that's all. So that is the answer to the question. Okay. This is a question on constraint motion. Similar question we have already done in tension force, but here we also have to consider the friction. So there we assumed that all the surfaces are smooth, so we ignored friction, but here we also have friction between these two blocks. But there is no friction between the block and the ground, right? So that friction is 0, mu is 0, but there is friction between these two blocks. Okay, yes. First of all, for questions of this type, you have to find the relation between the accelerations of these two blocks. See, when that block A moves to the left, what will happen to the block B? The block B will also move along with it to the left, which means block A and block B have the same acceleration in the horizontal direction. But in addition to that, the block B will also move down, right? So it will also move down because the string will loosen, the block will move down. So it will have acceleration in two directions, not only in the horizontal direction, it will also have has a downward acceleration. So which means you have to consider the resultant. Okay, first of all, the horizontal acceleration of B is same as the horizontal acceleration of the block A, because they are always, right, they are always in contact, which means they move together to the left. But this block B also move downwards. What is the acceleration of B? Okay, so we have many methods, right? So we have done some 3 or 4 methods to find the relation between the accelerations. What is that? Let us use the tension method. What is the tension force acting on the block B? So only that string, right? T is the tension. So T multiplied by tension multiplied by acceleration, right? Tension multiplied by the acceleration of B. And similarly for the other block. But the other block, what is the total tension force? T plus T, right? The 2 strings are attached to that. T plus T. 2T is the tension. So that means this is plus 2T multiplied by the acceleration of A, that equals 0. This is the method we used, right? So tension multiplied by acceleration. So that sum is 0. So this will give you the relation, the acceleration of B equals 2 times acceleration of A. I am not considering the negative sign, only the magnitude enough. But what is this AB? This AB is the acceleration of B in the downward direction, not the total acceleration. This is acceleration in the downward direction. See, this is block B. This is block B. So it moves in the downward direction and it also moves to the left. Okay, but the downward acceleration, so that is acceleration. Okay, so that is say, let us take this is A2, this is A1. So 2 components. But this A2 is same as acceleration of B, but that is same as 2 times acceleration of A. Okay, but what is acceleration of this in the horizontal direction? That acceleration is same as the acceleration of the block A only, because they move together to the left. So acceleration of A1, that is same as acceleration of A only. So essentially what we have to find is the acceleration of A. That will give you both the values A1 and A2. So let us find the acceleration of that bigger block A. Okay, yes. So let us find it. So we got the relation between the acceleration. You tell me, what are the forces acting on the block B? Okay, what are the forces acting on the block B? Yes. So block B, what are the forces? In the vertically downward direction, so we have the gravitational force, right? Or you can take the horizontal direction. What is the only force acting in the horizontal direction? The normal force between B and A, right? So normal force, they are in contact. So normal force is what pushing this block in this direction, right? So normal force in this direction. So normal force in this direction, that equals mass times acceleration. So mass of that is m only, multiplied by the acceleration in this direction. So that is taken as A1. So m A1. But A1 is same as the acceleration of that block, right? So that is m multiplied by A acceleration of the block A. Okay, that's all. This is one equation. Now we have to consider the vertical. Okay, vertical motion. What are the forces acting in the vertical direction? Mg in the downward direction, gravitational force mg. And then tension in the upward direction, so minus T. And also the frictional force between these two blocks, right? Friction, right? This is the rough surface, frictional force in the upward direction, opposite direction. So what is the frictional force? Minus the friction formula is what? Mu times the normal force. Okay, mu times the normal force between these two. So that equals mass times the acceleration of this block in the downward direction. So that is taken as A2. So m A2. But what is A2? A2 is same as AB, that is 2 times this one. So 2m acceleration of A. Okay, so these are the two equations, okay, for the block B. Now similarly for the block A, so this n can be substituted here also. Okay, let me substitute here. So this gives you the value mg minus T minus mu normal, but normal is m multiplied by acceleration of A, m multiplied by acceleration of A, that equal to 2m acceleration of A. Okay, yes, okay, anyway we can use it later. So now for the other block, so block A. So what are the forces acting on the block A in the horizontal direction? Two tension forces, right? Tension due to that string, and below we have another string. So T plus T, 2T is the force acting in this direction, and normal force between these two blocks. The normal is pushing this block in that direction, right? So 2T in this direction, one normal in that direction. So 2T minus the normal force due to that block, so that is in the opposite direction. So this equal to mass of that object is same m only, multiplied by the acceleration of that block, so that is same as, okay, acceleration of A. Okay, so that's all. Okay, so this is one relation. So we've got the relation. So here also we've got one relation, but n is already known here, so this gives you the relation. So 2t minus, what is this n? N is equal to mass times acceleration of this. So mass times acceleration of this equal to m times this one. So this is 2 times this one, 2ma equal to 2t. So that will give you t is equal to m acceleration of a. Okay, that's all. This is also one relation that can also be substituted here. Okay, let us substitute this here. Okay, so that will give you our required value of acceleration of a. So what do you get, tell me? So mg minus tension, but that tension is found, m multiplied by acceleration of a minus, this is same, okay, mu m acceleration of a equals 2m multiplied by acceleration of a. Okay, so m gets cancelled, so that will give you the required acceleration of the block A. So that equals, okay, let us calculate that. So this is g divided by, so acceleration of A, so acceleration, so that we can divide. So this is 2m, okay, 2m, so plus m, so that will become 3m, so mu, yeah, so that means g divided by mu plus 3. That's all. So this is the acceleration of the block A. We want to find the acceleration of the block B, but the block B has two acceleration, right? Two directions. So one in this direction, one in this direction. So this direction we have acceleration of A. That's what we found here. In the downward direction, 2 times that acceleration. So what is the acceleration of the block B? So that implies the acceleration of the block B equal to, so we have to take the resultant. How to take resultant, right? These two are in perpendicular direction, square root of this square plus this square, right? So that will give you square root of this square, that is acceleration of A square plus 2A, downward 2A. So that means 2A, 2 acceleration of A square. So that gives you the acceleration of A square root of, okay, this is 1 plus 4, so that is 5. That's all. This acceleration of A we have found just now, so that is g divided by mu plus 3, so that we can substitute there. So we'll get so g root 5 divided by this value mu plus 3. That's all. So this is our required acceleration, right? So little bit of constraint motion we have to use to find the relation between the accelerations of these two blocks. Okay, so the rest of the things same thing, right? So the forces acting on the blocks we have to consider, so solving the equation, that's all. So because the block B has accelerations in two different directions, right? It is not horizontal or vertical, it's going in some angle, right? We have to find the two components A1 and A2, so square root of A1 square plus A2 square, so that is the acceleration of the block B, right? So that happens to be this value, g root 5 divided by mu plus 3. Okay, we are done with all aspects of frictional force. In the next class we'll do pseudo force. Okay.